about a project titled A Survey of Human Action Recognition and Posture Prediction. So now coming to the introduction part. In the realms of computer vision and human-computer interaction, precise identification of human actions and anticipation of postures are essential for machines to comprehend and respond to human behavior effectively. With the progression of technology, the interdisciplinary area of human action recognition and posture prediction has garnered considerable interest. This survey delves into various approaches, obstacles, and applications within these domains, seeking to offer a thorough overview of the present research status and progress in comprehending and forecasting human actions and postures. So now coming to the objective part for this project is to present an extensive and current summary of the latest techniques, methodologies, challenges, and applications in these crucial areas of computer vision and human-computer interaction. This survey strives to capture the broad spectrum of approaches utilized for recognizing human actions and forecasting postures, encompassing traditional computer vision methods as well as state-of-the-art of the deep learning technique. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. Second, here we have exploring the dataset, action and post dataset, merging image and label YOLO files, reading the image, loading and reading files from the dataset, plotting the image, creating visualizations of the image. Next here we have image processing, converting to blob object, transforming images into blob objects. The next here we have defining the class, specifying the class of object, declaring the boundary box, defining the bounding boxes for the object, converting the array into a NumPy array, converting array to a NumPy array. Then next here we have loading the pre-trained model, reading the network layers, loading and reading the layers of the pre-trained model. Second here we have extract the output layers, extracting the output layers of the pre-trained model. Then we have image processing, appending the image, annotation files and images, combining image data with annotation files. Then we have converting BGR to RGB, adjusting the color format of the image, creating the mask, generating a mask for the image, resizing the image, adjusting the size of the image. Sixth here we have data augmentation, randomizing the image, applying randomization to the image, rotating the image in this. Then we have transforming the image, applying the transformations to the image. Eighth here we have installing the packages required for YOLO V5 in Colab, setting up the necessary environment in Colab by installing packages required for the YOLO V5. Ninth we have processing the data based on the YOLO V5 model, preparing the data specially for training the YOLO V5 model. Next here we have building the model in Colab, YOLO V5 constructing the YOLO V5 model, YOLO V6 constructing the YOLO V6 model, mask RCNN building the mask RCNN model. Then we have training the models created in Colab using the prepared data. Then we have building the model, constructing the models for detecting objects or actions in images or videos. Then we have class framework with SQLite for sign up and sign in, setting up a web application using class and incorporating SQLite for user sign up and sign in functionality. Then we have user gives input as image or video. User provides input in the form of an image or video for the model to make predictions. Then we have the given input is pre-processed and the trained model is used for detecting the license plate. Adjusting the shape of the input image, pre-processing with the trained model, pre-processing the input using the trained model for detecting the images or actions. Then we have the segmented each object and put bounding box. The identified objects or actions are segmented and bounding boxes are placed around them. And the last one here we have final outcome is displayed through front end. The model's predictions and outcomes such as segmented objects with bounding boxes are displayed to the user. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages which is used in this project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then the other folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. The next here we have .ipynb file which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. The next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. Then we have signup.db file. This file appears to be the database file which is used to store the information. Just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 and is configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. And I'm using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is a home page for the survey of a human action recognition and posture prediction. So it is all about the Mask RCNN ArrestNet, Human Action and Post Recognition YOLO V5. It is about the human action and post recognition. So here you can see that there is a button for sign up. Just click on this button and this is the registration form. Just enter your username, your full name, your email ID, your mobile number and your password over here for doing the registration and click on register button. I have already done the registration, so here I am clicking on sign in button. This is the login form. Just enter the username over here and the password over here which you have created while doing the registration and simply click on login button. Click on OK. And here by scrolling down below you can see that it is asking for uploading any of the image. Click on choose file button and let me choose the image. So here you can choose any of the image from this. Suppose that I am choosing this image and now simply click on open button and click on upload button. So here you can see that it is showing the image that arms are crossed. So depending upon the image you are providing over here, it will detect. Let's try with another image. Click on choose file and let's try with another image. Let us try with this image and click on open button. Similarly click on upload button and here you can see it is showing again that the arms are crossed. So depending upon the image you are providing over there, it will detect the posture prediction. So here you can see that there is a button for sign out. By simply clicking on this button you can successfully log out with this. So now coming back to the conclusion part. In summary, this survey offers a comprehensive examination of the complex and dynamic terrain of human action recognition and posture prediction in the fields of computer vision and human-computer interaction. By conducting a thorough review encompassing methodologies, challenges and applications, our goal has been to encapsulate the essence of the present research status in these critical domains. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.